All right, last class, whenever we found the vertical and horizontal asymptotes, we had something like this. So what would, my vertical asymptote would be what on this? X equals -4. My horizontal would be what? Y equals -7. All right, so today we are going to look at how to find the horizontal asymptote. With something like that. Okay, so I want you to really see these as two different problems, and the way to identify it is what's in the numerator. Is it just a number, or is it an equation? Finding the vertical asymptote will be very similar, but it might involve factoring. Okay, we might have to factor it and set it equal to 0. Then we'll be able to find that vertical, the vertical asymptote. Okay, so going to the front of the notes. There's going to be 3 different situations that you need to look for whenever it's like this. And you're looking at the degree of the numerator and the degree of the denominator. Okay? By the degree, make sure, no. By the degree, what I mean by that is the largest exponent. Okay, so if you look at this example 1 down here, I would say this has a degree of 2, this has a degree of 2. A degree of 1, a degree of 2. A degree of 1, a degree of 2. 2, 1, 2, 2, 3, 2. Okay, so you're going to look at the degree of the numerator, and you're going to look at the degree of the denominator, and you're going to compare the two. And there's really only 3 things that can happen. Either the numerator is larger than the denominator is larger than the numerator, or they're the exact same. So the first thing, if they are equal to each other, you're just going to divide the leading coefficient of the numerator by the leading coefficient of the denominator, and that is your horizontal asymptote. Okay? So the leading coefficient what that means, that is the, for lack of a better word, the lead number with the degree, which we define what the degree is. Okay, so those are kind of a couple definitions you need to know. So this one would have a degree of 2, the leading coefficient is 2. This has a degree of 2, the leading coefficient is 1. This has a degree of 1, the leading coefficient is 4. Okay, so if they're the same, I'm going to divide those 2 numbers, and that's my horizontal asymptote. If the numerator is less than the denominator, you don't have to do any math. It's y equals 0. If the degree of the numerator is less than the degree of the denominator, then it's y equals 0. If the degree of the numerator is greater than the degree of the denominator, there is not a horizontal asymptote. Okay, so those are the 3 situations that we're going to look at here. So let's kind of go through some examples just so you can get in the habit of looking for, make sure you know what you got to look for. So on example 1, Case, what is the degree of the numerator? 2. Yep, that x squared. Tanner, the degree of the denominator?
1.
What is right there?
2.
2. Okay, so those are the same. So we do this first rule right here. All right, Casey, what is the leading coefficient of the numerator? 2. Sierra, what is the leading coefficient of the denominator? Do what? 1. So my horizontal asymptote, 2 divided by 1 is 2. So there it is. of the numerator?
Just be 1.
1. Jade, what is the degree of the denominator?
2.
Okay. If the numerator is less than the denominator, what is my horizontal asymptote? Y equals 0, automatically. On number 3, Ray, what is the degree of the numerator? 3. And Peyton, what is the degree of the denominator? 2. If the degree of the numerator is greater than the denominator, what is my horizontal asymptote? There isn't one. Okay. Going to, I'm not sure why they're numbered they're lettered A, B, and C now, but EJ, what's the degree of the numerator? 1. Larkin, what's the degree of the denominator?
2.
If the numerator is if the numerator is less than the denominator, what's my horizontal asymptote? Y equals 0. On letter B, Journey, the degree of the numerator? 2. Kelly, the degree of the denominator? 1. If the numerator is greater, then what is my horizontal asymptote? None. Okay, so hopefully you're kind of getting the hang of what you're looking for here. Eden, degree of the numerator, degree of the denominator. So, Roslyn, what do I do with the leading coefficients? So what would my horizontal asymptote be?
3.
Awesome. 3 divided by 1. Okay, so if you have rationals that look similar to these, this is how we're going to have to find the horizontal asymptote. You need to memorize those rules. Okay. I'm going to go ahead and tell you this. The first one's pretty easy. Okay, same degree, divide. Most people can remember that. A lot of people will forget y equals 0. Which one of these does it go with? Okay, a lot of times they'll mix those rules up. So you need to make sure to memorize them. And what I would do come test time is right whenever I hand you that test, that's something I would jot at the top of my test. Okay? Alright, coming down to here. So what is a hole? Last time I told you that, we were starting to kind of identify what the different kind of excluded values we would have. One was the vertical asymptote. The other one is going to be what is called a hole. Okay, so if you remember, on a lot of those problems where we canceled stuff out, the addition, subtraction, all that stuff, where we would cancel something out, we're now going to do something with what we cancel out. Alright, so we're kind of getting to that point. So, the definition of a hole, what we have is when the same factor is in the numerator and denominator, then there is a value x where f of x equals 0 divided by 0. So, where you have an excluded value. At any point xy, the function does not exist. So, when I say that there's a hole in the graph, that's literally what it means. That's not just some weird math term. There's a gap in the graph where if we zoom in close enough, and you won't be able to see it in your calculator, but if I'm graphing it, and how we're going to graph it is we're literally going to draw a hole and continue on like that once we get to the graphing part. So let's walk through this first example. Does anything cancel? X minus 2, okay? So everything cancels. I need to go ahead and write what I have left, which is just going to be x squared. So to find the hole, the first thing you're going to do is set what you canceled to 0. So what's that going to equal? 2. That is the x value of your whole. And anytime you have an x value, what do you have to do to find the y value that goes with that? Back to day 1, algebra 1. Eden, plug it in. Okay? And what is 2 squared? What? Okay, thank you. It's a little scary. So on this problem, that is where the whole would be located. Okay, x cannot equal 2. You know, like I said previously, we called these excluded values. Now we're just expanding on it. Okay, that's why it can't equal 2, because there's a graph there, or there's a gap in the graph. Alright, so I'm going to do the first one. Okay, and this is probably the toughest part of today's notes. Then we'll get into actually the whole process of graphing a rational function. So, on D, we're going to factor this. The very first thing, you always have to do is factor where you can. Can I factor the numerator? Yes, what can I do? Pull a 4 out. Can I factor the denominator? Yes. Becomes that x plus 3, x minus 3. So now that I'm here, Matthew, does anything cancel? X minus 3. So if I canceled out x minus 3, what's the x value of my whole going to be? 3, because I would set that equal to 0. X equals 3. EJ, what do I need to do with that x value to find the y value of my whole? Plug it in. So I'm going to plug it into what I have left, which is just 4 over x plus 3. So 4 over 3 plus 3, which is 4 over 6, which I can reduce to 2/3. Don't freak out if you get a fraction on these. I would probably say you're going to get more fractions more often than you do a whole number for that y value. Okay. So going to E, can I factor the numerator? What factors of 10 add up to 7? 5 and 2. I want you to go from there. I want you to find the whole on that, and then I want you to go to letter F. I want you to go ahead and factor that one as well. And I want you to do the whole process on that one. I'll be a couple minutes behind you. I'll also be walking around answering any questions you have. You should have been able to cancel out x plus 5. Now, listen, I want to make a point, and I didn't emphasize it enough on the previous example. And it was a good question. Case asked me, well, how do I know what to plug it into? Okay. Whenever you cancel out whatever cancels, the very next thing that I always do is I write what is left. What remains after I've canceled that out. That's what you're going to plug it back into. Okay, that's from here on out, that's going to be the equation you're going to work with, whether it's that or it's graphing, anything like that. So on this one, you should have gotten that the x value for your whole was -5. And then if I plug that back in for x, I get negative 3. Okay. So if you have not started on F, go ahead and start on it. Okay, we'll actually not, go ahead and stop doing F. F has a mistake in it, so it doesn't come out to where there is a hole. So we won't do F, we'll just go ahead and go on. Okay, so coming down here, now we're going to get into these problems, and this really encompasses everything that we have talked about last class and this class. Okay, so we're going to find the vertical asymptote, we're going to find the horizontal asymptote, we're going to write the domain and range, we're going to find a hole. I'm not too concerned about the x and y intercept. We'll talk about it, but those would be the least of my concerns. So, first thing we always want to do is to see if we can do what? Factor, okay, which, because it's this, and let me retract that, I lied to you. I said it trying to get that answer though. With what we learned now, we don't want to factor first because we need those degrees, because the degrees help us find the horizontal asymptote. So, Callie, what is the degree of the numerator? 1. Eden, what's the degree of the denominator?
2.
If the degree of the denominator, if the degree of the numerator is less than the denominator, what is my horizontal asymptote? 0. And guys, what I would do is right whenever I identify something, I'm going to come over to the graph and I'm going to graph it. Which that line isn't very good there. There we go. Okay, so there's my horizontal asymptote at y equals 0. Once I'm done with that, and if you hadn't noticed, you got the nice steps all written out up top. I'm going to factor that if I can. Can I factor the numerator? Yes. What can I pull out of it? 4. Can I factor the denominator? What does that become? Will anything cancel? What? So now I'm left with that. Okay? Now I canceled out x plus 2, so what is the x value of my hole? Negative 2. Okay. I would then take negative 2 and plug it back into the resulting equation. So I would have 4 over negative 2 minus 2. That's going to give me 4 over negative 4, which equals negative 1. Like I said, whenever we say a hole, I literally mean go to negative 2, negative 1, and graph, just put a little hole right there. Make sure that once you cancel stuff out, you're looking at this. But I mean, and that's an easier equation. You would want to work with that than the original one. What is my vertical asymptote on this going to be? 2. So I come over here.
Do the range stay the same, or do they change?
There's one thing we're going to have to add to the domain and range today. But it's the same idea. The negative infinity, positive infinity, x does not equal. It's going to be the same kind of idea. So once we have this, if you have a hole, and I've really been trying to drive home the whole, all right, if it's negative, make sure you got it in the right spot, okay? If you have a graph that has a hole, it does kind of help you, because whichever one of these 4 quadrants the hole is in, the part of the graph is going to be in that quadrant, and then also in the opposite corner. So, again, the curve, I'm not too concerned about the curve, but you do need to know that it will go to that right there, and then start to curve down. Okay, and this one's going to be pretty far away from that center point because that A value of 4 is going to affect it. So far with what we know, my domain is going to be negative infinity to positive infinity, except x does not equal what? 2. Because there is essentially, there's a gap right there because of the asymptote, right? Is there another gap in the graph? Sierra? The x value of the whole, negative 2. Your range, same thing, but with y. And what is y not going to equal on this, Tanner?
2.
What's my horizontal asymptote?
0. Oh, that's not equal to
And negative 1. Okay. So I don't think there's a spot at the bottom. No. So underneath this graph, since this is the first time we've done this, let's go ahead and write this. This is going to be the blue, kind of think of it as the blueprint of how you're going to write your domain and range. It's going to be all real numbers. That's the same as negative infinity to positive infinity. But x does not equal your vertical asymptote and the x value of the whole. Your range is all real numbers, except y cannot equal the horizontal asymptote and the y value of the whole. Okay, I'll give you just a couple seconds to make sure you finish that out. Then we'll talk about the x and y intercept, which it's not a huge deal, but it's good to know how to do it. Okay, so for my x-intercept, there's kind of a thing, this one should be pretty easy to find on this one because where is my horizontal asymptote?
0.
It's y equals 0, and that is right on top of the what? X-axis. So is the graph ever going to cross the x-intercept? But this is yes, this is no. No, okay, good. So on that one there is none. For your y-intercept, you're going to just plug 0 in for x. So I would have 4 over 0 minus 2. 4 divided by negative 2, which would give me a y-intercept of negative 2. Which means I was kind of close to getting it accurately. You want to have that graph somewhat crossing right there at negative 2. Questions on all of this? Yes?
Okay, so how I think it was last.
So looking at that, Cam, what is the degree of the numerator?
2.
2. Case, what's the degree of the denominator? 2. So Casey, what is my horizontal asymptote? 1. I divide my leading coefficients. 1 divided by 1 is 1. So again, I'm going to come over here, and I'm going to go ahead and graph my asymptotes. Right when I know where they are, that's going to start to give me a picture as to what this graph is going to look like. Next, I want to factor. Journey, my numerator is going to be what whenever I factor that one?
X minus 1, X plus 1.
Awesome. X minus 1, X plus 1. And the denominator, whenever I factor that, that is going to be X plus 2 and X minus 1. Is anything going to cancel here? X minus 1. So I end up with X plus 1 over X plus 2. Chris, what is the X value of my whole going to be? Yeah. What did I cancel out?
The minus 1.
X minus 1. So I want to set that equal to 0. So X equals 1 for the whole. And then Callista, to find the Y value, what do I do with that 1? So I've got the X value of my whole. What do I need to do to find the Y value? Just plug it back in. So I would have 1 plus 1 over 1 plus 2, which would give me 2/3. So I'll go over to the graph, and roughly at 1 2/3, I'm going to put a hole right there. After that, Peyton, what would my vertical asymptote be? So we're dealing with this right here. So if I set my denominator equal to 0 and solve it, what would that give me? -2. So X equals -2. Okay. I don't have it graphed yet, but I can go ahead and write the domain and range. So EJ, what two values would the domain not equal? -2 and 1. Awesome. Lauren, what two Y values would the range not equal?
1 and 2/3, right?
1 and 2/3, yes.
Oh.
Awesome. Okay. Alright, so we're not going to go through the X, Y intercept, but we do want to go ahead and graph this. Okay, so again, it's roughly going to be there and there. Okay. Any other questions on this before we go on to the last one? I think the last one. Yeah. All right, going to the last problem. I want you to attempt this one, and I'll be a couple minutes behind you. So because the degree of the numerator is greater than the denominator, you should have found that there was no horizontal asymptote. There it is, factored. I'm going to have a hole at 2, 6. So, what kind of graph do I have? Linear. So, let's review how to graph a linear line. What is my y-intercept? If I have y equals x plus 4. Yep, that's why we're doing it. What is my y-intercept? 4. Remember, you graph it from the back, from the end of it to the beginning. What is my slope? 1 over 1. So I can go up 1 over 1, up 1 over 1. There, that's where the hole's at. And so there is there's my line right there with the hole in there. If I have no denominator, I'm not going to have a vertical asymptote, if you hadn't already noticed that. Forgot to put that in there. Okay. There is no denominator to set equal to 0. There's nothing there to be done. Now, the good thing about this is if you end up with a linear line, linear versus rational functions, you're still going to have that. Okay? But what x value is not included on the graph? 2. The x value of my hole. And what y value for the range? 6. So, what I would do whenever you're working through your homework, have that handy. Those are just all the steps that you need to walk through each problem.